Hi everyone. Uh, First of all, I want to say thank you to Uri and Virtual Biases for organizing this webinar and invite us for this talk. My name is Amnon. I'm a machine learning engineer at Pinecone. And today we are going to talk more specifically about RAG evaluation. This is a topic my team and myself have been working in the last year a lot because we are trying to help customers to be successful with RAG. We have a lot of topics, so let's just get started. So what we are going to cover today is the following. We're going to start giving some motivation that actually going to be very similar to the motivation Scott gave us for why it's important to evaluate RAG and why it's challenging. And then we're going to just share our own experience from using popular RAG metrics and where they are failed, at least for our use case. We're going to really deep dive into the solution that works for us. And finally, if we have time, we're going to talk about how to build scalable experimentation framework and just describe things that seems to work well for us. Overall, we try to give us here like a very practical um, lecture, like a talk that really just follow our journey into the world of RAG evaluation. Okay, so we're gonna start with some motivation. Um, what we see usually with customers is like it's very easy to build a demo for RAG. There are tons of YouTube channels that teach you how to do it, tons of libraries like LangChain or Llama Index, Canopy, etc. And like Scott said before, it's very easy to get started, build a demo. But going to production is very hard, and specifically with RAG, it's kind of even harder. There are a lot of because there are a lot of failure points. For example, you can fail on parsing your documents, or maybe you chunking, like the way you split your documents doesn't work well. Maybe your model hallucinates information that doesn't exist in any document, and many more issues that can come up in production. So obviously there is like only one solution here. You just need to try stuff, evaluate and see what works, like try and error. So you need to go in this cycle of experiment some idea, evaluate it, and learn what works and improve over time. This is like the key way to succeed with LLM applications. But this is not an easy thing to achieve, especially the evaluation part is hard. When we started to work on this problem, we find out that first there are very few high quality public datasets for RAG. Just briefly mention what is problematic with most of the public datasets. It's like a lot of them are only on passage retrieval. In real world, you have like full documents, and a lot of them don't contain maybe answers, just relevant documents, and many other issues. We really like one dataset that we find that is highly challenging and suitable for RAG is a new dataset called Finance Bench. This is a financial question answering dataset. That the benefits we see in it is that like it works in document level, not just passage level. And also it requires for you a lot of complex reasoning because it's asking a lot, like it's combining different numbers, do a lot of calculation, etc. So in this talk, we're gonna focus on this data set. In the appendix of these slides, I put some other data sets we think are worth using. Um, so again, like what we say here is like the challenging in evaluation is first that it's hard to find high quality public data sets. Obviously, if you have your own users' data or proprietary data or anything, this is better than using public data sets if it fits your use case. And the second problem with the evaluation is that there are currently no any standard metric for RAG. Hopefully in the future there will be, but right now when you try to figure out which metric to use and how you evaluate your system, it's very hard to find some metric that everyone uses or something like this, like happens in like many other machine learning or AI fields. And now we're gonna try to understand like why it's so hard to define metrics specifically for RAG or in general GenAI. So let's look at this query that is similar to queries in Finance Bench. For example, we might get a query saying, did Nike's debt increase from Q4 fiscal year 2023 to Q1 fiscal year 2024, and what caused this change? So then you get maybe two responses from different RAG systems, and you need to say like which is better, or either get some score for each response. And this is like very challenging. First challenge is that you need to know, like you see, each response provide different numbers, and you need to say like you need to know what are the correct numbers. This is not always an easy thing to know. And another problem is that you can see that the right response is elaborate much more, like it gives much more causes for this change, etc. And it's very hard to say what a human would prefer. Like either a human should prefer, like it's not clear if you should prefer a shorter explanation or longer explanation. So just cover this up briefly. It's very hard to define metrics because it's not that easy to know like what is factually correct when you use a RAG application. And secondly, it's very hard to tell what a human would prefer with an automatic metric. So first thing we tried is to say, okay, let's just try out what is most popular. And we find this idea of a RAG triad. This is something very popular that Truelens uses, or Ragas, this kind of frameworks. And the idea works like this. The idea is that you can do unsupervised evaluation. It means that you don't have any ground truth and still you want to have a metric. So how it works? First thing, our ingredients going to be the model response, the query the user provided or the chat history, and the context retrieved from my R system, because in RAG usually we first get some context, feed it to the LLM, and then get a response. And so this is going to be the nodes of this triangle, and the edge is going to be metrics. So one of the most popular metric is groundedness, and the idea is pretty simple. You get the retrieve context from your IR system, you get a response, and then you ask an LLM whether all the facts in the response are supported by this retrieve context. You can find groundedness with different names like faithfulness, etc. But the idea is to validate the factual correctness of your RAG response with respect to the retrieve context. A complementary metric is answer relevance. The idea is that you take the user query or chat history, the RAG response, and you ask whether the response is fulfilling the query. This is complementary because you can take a RAG system that just randomly picks some facts from the retrieve context and spill it out. You're gonna get perfect grounded score, but this doesn't necessarily fulfill the query, so you need this answer relevance to make sure you count for both things. And thirdly, there is context relevance. The idea is that you take the user query and the retrieve context and you ask an LLM whether the context is relevant or not. This is kind of second order metric because it's not like end-to-end as looking at the response. It's help you to debug and understand whether a retrieval succeed or not. So this idea is very cool because it's unsupervised. You don't need any human annotations, and you only use LLM, so everything is fully automated, and you can do it even online on like production data. And we tried this on Finance Bench, and the way that we thought about like before we just committing to this idea, we wanted to see whether it correlates with humans. So what we did, we just run some very naive RAG system on Finance Bench, and then let humans to annotate the response and check for correlation with these metrics from Ragas in this example, which is again a framework for unsupervised metrics for RAG. And what we find out is that the correlation is actually very low. This is like a confusion metrics, comparing the human annotations and the LLM score from specifically for Ragas. I put in the slide some more details about how we run this experiment. And what you see here is that the false positive rate, which is the left low box box here is very high, which is not good. It means that we have a high false positive rate. Means that in many cases where a human would say the answer is wrong, actually our metrics thought it's right, like in 94% of the time. And if you look at the higher picture here, Ragas, in this case specifically, always said that the model was right, which is like kind of not helpful for us to compare different RAG systems, right? So then we thought like, try to investigate what's failing here in the idea. And we think that the main idea and the main problem here is that we use unsupervised metrics. We see, for one example that I remember, is that we found out for example, like there was a question about some calculation and the PDF parser just didn't find the minus sign, and then all calculation was reversed. This is something an LLM that used the parsed PDF can't see. Only a human that look at the PDF and can see the minus side could capture this issue. And the most common issue with this unsupervised metrics idea, at least for Finance Bench, is that sometimes the question can be, for example, about the depth of a company, and there is a document with some amount of depth, but it's not providing the full picture. And then all the unsupervised metrics just use what there is there and assume everything is okay. But a finance analyst or an expert will see the full PDF and really know which table to look at and find the most accurate answer. So what we thought about doing here is actually going back to supervised metrics. And the idea is very simple. You just need to have ground truth answers for your data set, for the set of questions you usually keeping iteratively evaluate against. And the idea is that you just, what we're going to describe in the metric we're going to use, we just ask a human to write, or an expert to write an answer for each question, and then we measure some accuracy automatically using an LLM. Another thing you can do, you can ask a human to give you a snippet of text from the corpus. This will be the ground truth context, and then you can measure standard or classical IR metrics like recall and NTCG. But today we're going to focus on this accuracy, or generally how to compare responses to ground truth answers. One thing to note here is that the downside of doing this is that you need human annotations because it's costly. The upside is that we're going to show how you only do it once, like you do it one time to your test set, and then you can use the LLM to keep evaluating for this test set, so it's not that costly. And the main reason we believe, at least for this kind of data sets, you want to use supervised metrics is that usually you use LLMs for out-of-domain or out-of-domain tasks. This is why you use RAG. And for these cases, if you want to evaluate, you need some expert from this domain that give you some information to your evaluation system that will help you do a high-quality evaluation. Cool. So now what we're going to do is just do a very deep dive to how this metric works. We're going to use the same query we used before. Did Nike's depth increase from Q4 to Q1 fiscal year 2024? What caused this change? And first thing we do is we ask a human to provide us a ground truth answer. It says, yes, Nike's depth increased from 8.927 billion to about 8.3930 billion in that period. The primary reason is higher shareholder returns. Now we run some RAG system and we get another response with some numbers, etc. And what we want to do is we want to compare this RAG response to the human ground truth answer. This is not trivial task at all, because you can see the phrasing is different. Some of the numbers are the same, some are not. So this is what we came up with. We do something in 2 steps. First step, we take this ground truth answer written by a human, ask an LLM to generate a list of facts out of this ground truth answer. So for example, Here you can see that each number like got its own fact, and the reason for the increase is another fact, etc. And this is actually not a very hard task for LLMs to achieve from our experience. Next step, we take another LLM or the same LLM and ask it to give a verdict per fact. Okay, we're gonna go one by one for these facts and just annotate it with like classic NLI classification, like whether it's entailed, contradicted, or neutral. So let's go one by one. We see that first fact we want to evaluate is whether Nike's debt increased between Q4 fiscal year 2023 and Q1 fiscal year 2024. So what we need to do now is to check if this fact is entailed by this response. We see that the response says Nike's debt rose. So this is entailed. Next, we're gonna verify this fact, saying that in Q4 2023, the debt was 8.297. This is the same thing exactly our RAG system says, so it entailed. Here we see different numbers. This is 8.3, this is 9.21, which is different, so this is contradicted. And what is to notice here is that our RAG didn't address at all the second question, like what caused this change. So this is neutral, and it's something we want to punish the model because the user asked for the cause and the RAG system didn't give anything here. So what we do now, once we have this verdicts per fact, we're gonna calculate recall, precision, and F1. So recall going to be just the amount of intel facts out of the total number of facts we evaluated. So we have two intel out of 4. It means recall 0.5. For precision, what we're gonna do, we want to know from all the facts that the model, that the RAG system addressed, how much was entailed. So we have actually only 3 facts that the model actually addressed, and only 2 out of 3 was like entailed. 1 was contradict, or simply put, precision is going to be number of entailed divided by number of entailed plus contradicted. So we have 2 out of 3. This is 0.66. And F1 is just F1, it's just a harmonic mean. It's like 0.57. This is very helpful for us because usually you want to have like a single metric that you can easily compare to system and say, which is better. Cool. So after we did run this idea, we wanted to reevaluate and see if it's correlated with human annotations. We just reuse the same human annotation we had before for finance bench, and actually the correlation was much higher. So if you remember, with Tragas we got like a false positive rate of 0.94. Now we almost like, it decreased from 94% to less than 3%, which is great. We see a little increase in the false negative rate, but this is no-brainer because, if your system always say that the system was right, you can get a very low FNR. Overall, when you look at this number, this is very low, and we were very happy with it. This is something that really is useful and help us to compare to several RAG systems in a meaningful way. And the general takeaway maybe here is that if you're thinking about your metric or anything, maybe you should consider this idea of just annotate by yourself and check for correlation. The cool part here is that you can annotate one time and just keep comparing automated metrics against these human annotations. Just a quick note about limitation of this metric because it's not perfect. First of all, we assume here that we have the ground truth. It's not always the case. We don't consider alternative correct answers, which is sometimes the case. In finance bench, it wasn't the case, but it might happen. And like always, there are multiple, like Scott said, multiple aspects you need to consider when you're building your full set of metrics. We didn't see evaluate conciseness, the citation correctness, whether if the model cite some source, whether it was a good citation or not, or many other aspects we don't cover here. So this is just a note about limitations. And now I wanted to give some insights about the prompt we were doing and what was the thinking about, like the thinking behind how to design practically this metric so it won't be too costly or too slow. So this is not the real prompt we use. This is like the sketch of it. You can find the full prompt in the appendix of the slides, and you shouldn't even read it here. All what you need to care is that in the prompt we provide the model the question. Like this is the prompt that help us do the evaluation we just described. We provide in the prompt the user question, the list of ground truth facts that we generated from the human answer, the RAG response, and then we ask it to produce some JSON, which JSON, this JSON. So the idea is simple. We have one single call to the LLM that by providing all the context like the question, the ground truth facts, and the response, we can get the verdicts one by one. And then once we get these verdicts perfect, we can just do a very simple calculation to get recall precision F1. So few things about this, like as you can see, we do it in one shot, like in one call to LLM, we generate the full JSON and then calculate. We don't need to do few calls to get recall and precision. So what's happening here actually is that in one shot, we can generate a very short output and get all the metrics and information we need. So it saves a lot of cost and latency. And one thing to notice that this ground truth facts looks like we need this call that takes the user, the human ground truth answer and generate a list of facts. What we can do here, we can do it as a pre-processing step, just generate one time before we start running evaluations, generate a list of ground truth facts. And this is saving us a lot of calls and also reduce variance because always we compare for the same facts. So the main point here, you can go over the details once you have the link to the presentation, is that we managed to get 3 metrics and everything just with one LLM call that produce a very short response. Another cool feature is that it's very explainable. Like once you try to understand why the LLM think the answer was right or wrong, you don't need to read a lot of text. You really see what is the specific thing you need to look after, because you have this dict that just maps you. For example, here is fact 3 was contradicted. You just look for it. Okay, so this was very technical details about how to design or think about designing prompts for LLM-based metrics. Okay, so we talked about this learn, experiment, evaluate stuff, and we focused mainly on evaluation. I want to do a very short brief on the experiment part. Like Scott also said before, this is a very important part. Once you get a metric that is kind of correlate with humans, actually your quality of your RAG system probably gonna be a function of how much experiments you can run and get evaluation for, because this is a function of how well you learn what works and what not. So it's very important to build, what we find out is that it's very important to build a very scalable experimentation framework. So now I'm just gonna briefly discuss 3 things we think are very important to get to this highly scalable experiment framework to work well. First thing is we think it's very important to make your system fully configurable. What it means is that to make a good experimentation framework, you want your system to be something that is fully configurable, but for example, for a YAML. For example, if I want to change chunk size, I just go to this place in the YAML, change this number. I want to change the model, change it here. I want to add or remove ranker. It's just something you do with the YAML. This is very important because then you can just generate a lot of YAMLs and compare them, you know exactly what changed, and just know what works. More practically, my team developed open source framework called Canopy. It's an open source framework for RAG. And we implement this idea exactly. And I link here for a specific place in the code where we do this idea of a configurable system. So once you get the link for this presentation, just check it out and maybe use part of it for your system. Next thing is that once you have your system configurable, you want your full or whole experimentation framework to be configurable. What we find out that works well for us is to have a YAML again that give, for example, a name for this experiment, then define datasets and metrics, and then define which system to run. And you can also define a grid set. For example, this YAML try different chunk size, and then run experiments, and automatically you get scores. This can save a lot of work of just writing this code that every time try all the stuff and report the score and stuff. You just define one YAML with dataset metrics and systems you want to compare, and then you just run it. For orchestration, we think that using RayTune is very helpful. RayTune in general is an open source project by Anyscale that know how to orchestrate parallelized processes, and RayTune specifically can help you describe this kind of YAMLs or JSONs, and it know how to run them in parallel and report results and do retry and really orchestrate it well. You can run it on a Docker, and then you get a consistent environment. And for reporting, you can use something like weights and biases, like Scott described. There you can see the results, track them, see where you fail or succeed, etc. So we really recommend using these tools for your parameter sweep experimentation framework. And last thing we built very quickly actually is we recommend to have a very simple and stupid annotation tool. This is something we built in 1 or 2 days using Radio. We are not, anyone in my team is not a UI developer or an expert. But today there are many tools like Radio that can help you write a very quick and dirty UI tools that help you just do an internal investigation. So specifically what we have here, you can see a query from Finance Bench. We can see what the model was predicting, ground truth answer. You can see that the ground truth facts, and we color them by the model, the LL metric verdict. We see what the retrieve context and what was the ground truth context, and then we can just annotate. What we have here is very simple annotation. You can give thumbs down, thumbs up. This is the human annotation we showed before that we correlate with LLM metrics. You can say what is the failure point. Then you can aggregate and say, okay, we need to improve generation more, we need to improve retrieval more. And free notes, so things that we can capture in the other stuff. All this is logged to a GCP SQL table, very simple. And then, this is very helpful. And the main point about this tool is that eventually with all this LLM-based metric, etc., which is very nice and automated, you probably want at some points in your development to just see where you failed, annotate, get some human feedback, etc., to really know how to improve your system. And we very close to the end. I just want to know that I put in appendix with all the links relevant to what I just discussed, and also the specific prompt, the full prompt we used for the metric I described. And last point is that I wanted to say that you are not alone. Evaluating GenAI or RAG specifically is highly challenging. It's an open research questions. Both the academia and industry working very hard to improve on this. And just my suggestion is be strong, stay connected to the community, see what other people are doing, and focus on your use case and just try things and see what works for you. Thank you.